All right, good morning. We are week 16, day 4. So this week we've been covering AI. We're learning about AI and LLMs. It looks like this last week you've learned kind of about AI models and the inputs, like the tensors that we can pass into them, and the flow through the model with the different layers and our output from that as a prediction. So today we're going to start talking about data pre-processing for our models. And this is something that you can expand and use not just with AI models. We're going to be using Python libraries today to help us with our data processing that you can apply to any other project you do with data. So we're going to kind of discuss a little bit about the importance of pre-processing. We're going to take a look at some of these common techniques we can use for it, and then jump right into a practical example and how we can use different libraries to help us pre-process our data. So right away, I'd like to hear kind of from y'all, why do you think, so we're going to be working with this water potability CSV today. So we've worked with CSVs a lot. And up to this point, we've just been using that Python CSV library where we just read and we can do some writing. It's pretty basic. But what's kind of some of the issues you may have run across before with CSVs that might be a problem that we would have to deal with? Why should we do some pre-processing of our data here in our CSVs? Any ideas?
When you say pre-processing, I mean, I would think maybe converting it from strings to if they need to be float values, maybe.
Okay.
Make, Making sure that they're the right data type after you bring them in, I guess.
Yeah,
So,
for sure. That is definitely something like if we were working with an algorithm that took in just integers, but we've got some strings coming in on our CSV, we'd want to go through that and kind of address those issues with our data before we send it through whatever algorithm we wrote to work with it. So the same concept goes with our models that we're going to be passing information into. If we're giving it data that's missing or bad, it's going to skew that learning model and it's going to mess up kind of our predictions. Just looking at this CSV right here, y'all might not be catching these things right off the bat. That'll come with time, but I can see immediately there's some missing values already. These commas here, I can see we're missing numbers. So that's not going to be ideal passing into our models. First off, I don't know if it can even handle missing values. So we'd want to work with that. There might be, I mean, I'll slow down here. Yes, handling our data and making sure it can go into what we're trying to um, use to manipulate it. So as Mike said, some making sure it's all a standard format before we pass it in. So some of our, and another, it looks like, I'm just going from the README here too. We can pre-process data also by relevance. So if we're looking at this, we get a whole bunch of different columns here. Um, but maybe let's say really with the problem at hand, I just want to know the pH and something else. So we can process this data to just pull out the information we need instead of taking in everything. That will slow it down. It's unnecessary. We don't need to pull in everything. We just need to pull in certain columns. We can also pre-process to normalize or scale data. Does anybody know what normalizing data means? or like scaling it. Silence. So in our README, oh, Mike, are you gonna offer your?
I guess what I was thinking, and I don't know if this is right, about normalizing data, but I'm thinking that it would, so for instance, like right now, we're dealing with these long float values, right? Maybe reducing everything down to the second decimal point, maybe. I don't, you know,
Mhm.
that's the only thing that I could think of is giving everything the same type of structure. Uh,
Yes, yes, that is essentially what standardization and scaling does for our data. I'm not super clear on the math behind it, but it typically scales data to a fixed range. So if we have some really crazy high values, it's going to reduce those down within a certain deviation of what our standard range is in all this data. So it makes it a little, I guess it will affect the performance if it's all over the place. You're going to have outliers and everything like that. So by standardizing the data, it kind of compresses it down to a better scale for us to work with. We can also pre-processing this, we learn, so our models take in tensors, correct? But this is just one big CSV file. So we're going to have to split down this data into how we're going to pass it into our model with those tester or tensors. So another pre-processing technique we'll do is split this data up into what we're going to use to train the model and then what we're going to use to test the model in its performance. So that's another pre-processing technique we will use. So the three most common techniques is we're going to handle missing data or change it to a standard format. Um, we're going to go ahead and normalize it so that everything's kind of within the same range. And then we're going to split it up so we can pass in training and testing data. Okay. So, like I said, we're going to work with this water potability CSV. And right here, we can see there's a whole bunch of different values here. And at the end, we are going to, our model is going to target and be able to guess if water is potable or not. We can see at the end here, our potability has values of zeros. And then we should have some points in there somewhere. It's probably further towards the bottom. Um, oh, I saw one. But this is basically 0 or 1 for if it's potable or not. And when you learned about the binary models yesterday, um, that is typically the output from those models is going to be a like one or the other, right? And it's a value between 0 and 1 that kind of gives you the likelihood. So if you're like 0.4 or 0.5, under 0.5, you're going to be at a 0. If you're over 0.5, you're going to be at a 1. Um, but our model is going to output something between 0 and 1 that gives us the likelihood of, is this water potable? Okay, so we're going to build a model today that's going to take in all these pH, hardness, solids, all the rest of this. It's going to be able to take this in and give us a guess on can we drink it or not. So that is our goal today with this CSV file. Okay, so now we're in our Jupyter. One of the libraries we're going to use first that's actually really handy working with just data sets in general, and this is something you can use across the board, is pandas. I don't know if anybody's familiar with the pandas library, but it's a pretty common data processing library used in Python. So if you have not gotten it installed in your virtual environment, just making sure you install that library so that we can use that. I've already done that before for this example. but we're going to see how it's going to make everything look so much nicer in a second. So let me add a code block here. We are going to import this library and give it an alias. And then we're going to load up this data in something that looks nice and is readable to us. So we're going to use this pandas library, and we're going to, kind of familiar to the CSV in Python, we're going to read CSV. So this is what you're going to use to read your data in. Depending on where, if you have, you can copy this file, or if you have the whole curriculum, if you made a fork of the curriculum, it might be somewhere, it might be under a different folder. You'll have to see, but depending on where this is, put in your file path here. Mine is in the same directory because I just threw it in there as my practice file. So I'm just going to target that CSV. Okay, and then we're going to print our data. So we can see how this, we're going to run all, or you can come over here and just run the code line by line, run above it or run below it. I'm just going to run all because it's the only code block I have. And it's really nice because it puts our output here instead of in the terminal down here. So it's easier to see. But look at how clean and nice this looks. We can see we have our columns here. The columns are continued down here. That's what this is doing. And then it gives us kind of a subset of our data here. So it gives us 0 through 4, and then it's like dot, 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 dot. You know, there's thousands more up to, and this is the end of our file. Awesome. Looks so much better. And you can use pandas for your personal projects if you're dealing with a data type thing like this. Really great. And there's all sorts of other things. You can look up the library, read through its documentation, and see what else you can do with it. It can be graphs. It's really cool. But for now, we are seeing how it's being analyzed and printed into our notebook. It looks great. It's almost like a SQL statement. You know, we query our SQL database and get everything in nice columns and rows. So just like in SQL, we can specify specific columns that we want to pull as well. So we've got our data here. It's pulled up. We printed it. I'm going to add another code block down here just to illustrate this. So if you're not familiar working in Jupyter, everything that's done up here, I can use down here too. So like data is defined. I'm going to be used that. I can call that variable down here and it's populated. So we are going to just grab one of the columns right now. So how we can do that is kind of how you might think. And we just reference it directly. So let's pull pH. And let's print that so we can see it. Okay, so now I'm going to execute this one. And we can see it just pulled all the pH values. Just grabbing that column. Awesome. We can also grab a row matching a number. So if we just want to grab, you know, all the data in row 2, let's print. We can pull it by using this iLocation. It's an integer location based indexing. So you're going to pass in an integer here, and it's going to find that location based on the index there. So if we want this 2, we can see it starts with 0, so it's just like our indexing here. So we'll go ahead and grab index 2, and it should return this line here. Let's go ahead and print that. We're going to run this, and it does. It gives us all the values within this 2 row. Okay. We can also grab, you know, a slice of rows, just like we do with our slice methods. So we can go from 2, let's go to 4. Let's grab 2, 3, and 4. So the last, oops, the last index is not inclusive. So if I put 5, it's not going to include index 5 in this slice. Okay, so this should grab us rows 2, 3, and 4 and give us that information. You can see it does. So these are different ways you can grab just little subsets of the data. Um, and we can, I mean, it's pretty handy to be able to, unlike the CSV where you have to go in and, um, gosh, I can't even remember how we grab information from this reading in the CSV. Similar, but this is nice. I can simply just do data and then the name and it will give me the whole column. So that's nice. Okay, so now we're going to start handling our data. Okay, that was just a little sidebar of things you can do to graph specific data's sets here. But I'm gonna, for this model, I want everything. You know, I don't want to cut out anything. I want to be able to pass in all this information to be able to determine if it's potable or not. But I can see we've got some, you know, not a numbers here. We got some null values of information, and our model is not going to like that. So we need to take care of that. One thing we could do, we can look at how many values are actually missing to see how we want to handle this. Because if there's just maybe one or two, maybe we can like plug in a default value. We can maybe take a value from somewhere else and just kind of put it in, or we can remove it. But let's go ahead and see how many values we have missing here. So I'm going to take this directly from the README. You're going to grab this. If it's null, it detects missing values. So we're going to grab our data. We're going to apply this, you know, is null to it to see who's missing values. And then we're going to add up all those fields that are missing values. And this is going to target, excuse me, everything in this data. We could do a small subset. Remember, we can grab just a column. So we can just grab pH by doing our data and pH and just look for fields within that column that are null. But we're going to grab everything. So let's run this. And we get this output here. This is going to show us we have 491 null fields in pH, and then we have 781 in sulfate. It's like we have quite a few that are actually filled out pretty well. There's no missing values in those ones. So this is just kind of a nice tool to get you to start thinking about how you want to handle this data. Do you want to just pass in, you know, the information that has all the values? But I don't want to pass in information that just has all the values. I want to handle this missing data. So what we're going to do, there's a few different things you can use to fill these null fields. And what we're going to do today is we're going to replace everything with the mean of that column. So I'm going to, let's see, we're just going to overwrite this one. We're going to use this fill NA, which will fill all those null values with, and this is where we pass in how we're going to fill it. We're going to take the mean of each of those columns there. And we're going to fill in place. Okay. So there's different ways you can fill data, and I'll kind of look at that a bit later here. Yeah, we can also, I'll look at that here real quick. We can also, I'm not going to run this, but you can take your data and we could just have that equal drop NA. So this is filling those null fields, and this drop is going to remove all the missing values. So it's going to remove everything that has something missing. That's not what I want to do right now. I'm going to try filling it with the mean. So let's go ahead and run that. It's not going to output anything because I don't have anything happening, but this should have taken our data. We can go ahead and print. Let's print our data and see now, because up here we saw, null values, but now the data should have everything's populated. Awesome. There are no null values showing up anywhere. Of course, we have a lot of repeats now. You can see because we took the mean of this column and plugged it in there. So may or may not work for what you're dealing with, but that will be your decision on case by case basis. Okay, so the next step we're going to do is we're going to scale and normalize our data. So Pandas doesn't have this capability easily built in. So we're going to pull in another library to help us do this standardization. And this is just something you can throw in for all data, just kind of as a habit, is the standardization. Let's make sure we have this library first. It's going to be this scikit-learn. So make sure you're in your virtual environment and you do a pip install of this scikit-learn. That's the library we're going to use. And again, you can look up that library's documentation and kind of look at what options you have to work within it. And I've already got it installed. Cool. So here, I'm just going to copy from our README today. And we're going to walk through what it's doing. Okay. So to use it, we have to import it. So from this sklearn, which is in that scikit-learn pre-processing, we're going to import the standard scalar. And so this will standardize features by removing the mean and scaling to unit variance. So it's a lot of math. But just we're going to use this to standardize. That's all I want to know. So here we're going to select our features and target. When you went through your binary models yesterday, you should have learned that you're going to have features that are being passed in, and your target is going to be what your output is, correct? So our features, if we look at our fields here, we can kind of see right down here, potability is referenced. So what is potability in terms of, is it our feature or our target? If we want to determine how potable is the water, is that going to be a feature?
Target, right?
The target?
Yeah.
Yep.
Want to drink it. Yep.
Yes, exactly. So potability is our target. So then what's our features?
Everything else?
Yes, correct. Everything else. Again, we can throw some stuff out, but we don't want to in this case. So we are just every other column is going to be our feature. And we're going to pass it all in to our model and get our target out. So
we're picking one row to be like, this is what potability should be, and then everything else is going to be based on that.
So when okay, so this CSV already has our potability on here, so this is already determined. But that's why we're going to take this data to train our model and then test it, because we can already see what the results should be. I don't know if I'm answering your question correctly.
Because you said target's one, features is everything else.
Yes.
So I'm trying to figure out what that one is that we are targeting. Is it the row? Is it the column? Is it the...
It's this field.
Okay.
So if we pass in a tensor that just has one row of information, which we will do at the end here, I expect to get back just one output, one integer output or float, I guess it's going to be, between 0 and 1, because our binary model is going to give us a likelihood between 0 and 1. on if it's potable. So a target in our case is going to be just one field. We are only looking at how potable it is. So that's just one column of information. But it doesn't have to be the whole column. It's just that one field. Hopefully it'll be a little more clear as we get through this. If I'm not sure if I'm answering that well or not. Let's
Yeah, I mean,
pretend.
yeah,
Yeah.
according to here, it looks like it's just the whole column. Target equals data potability. So it's that whole column is your
Yes.
target.
If we have a whole bunch of them, it's going to be it's the potability field. So if we just have one row, it's that one column slash field potability.
Okay.
Yeah. So yeah, we're gonna come down here. Our features. So okay, I like it the other way around. I like this up top just because it the way I think. Um, so our target, we've already determined how potable is our water. So our target is going to be that column, that field. And the features is everything else. So to grab everything else, I'm going to take the data and then I'm going to drop, which literally does what it sounds. I'm going to drop potability and this access equals 1. Can anybody guess what this means? I had to look it up. I didn't really quite know. Anybody who likes math should be able to know what this is. So this access equals 1. I'm not going to wait around. We'll just go ahead and this means the like up and down axis. So I guess 0 is side to side and 1 is up and down. So by saying axis equals 1, we mean this whole column. We're going to drop that whole column in our data set. And then, so once we drop that rest of the data set is going to equal our features. Okay. Now we do our standardization. So we're going to make our scalar is just going to be the standard scalar, which we imported. It's going to do everything behind the scenes for us. Our scaled features we're just transforming the features because potability is already either a 0 or a 1. There's no variance from that. So we're going to scale our features. We're going to use the scalar, which is taking our standardized scalar and then this fit transform features. So that fits to data, then transforms it. You can definitely look into it a bit more behind the scenes about what it's doing, but we pass in our features, it's going to scale it and standardize it for us. And again, I'm not going to be able to see an output when we do this. Let's print our features and see what that gives us. Okay. So once we do this, it throws out supposedly standardized data set for us. And just the features, we can see that potability is not in this data anymore because it is now assigned to target. Awesome. So we handled missing values, we standardized our data, and now the last step we need to do before we can start plugging it into our model is we need to split this up into training data and testing data. And then we're going to transform those into tensors because that is what the model expects as an input and go from there. So let's split it out first. We'll go ahead. I'm going to drop this print here and just rerun that. Okay, so I'm going to make another code box here. To split this data, we're going to use this library here. So again, from this this scikit that we just installed. We have this model selection, and then we have a built-in method called train test split. So it's going to split our data into training information and testing information. And we are going to copy this and put it here. Okay, and this is just from the README, and we're going to walk through what this does. So we are assigning a whole bunch of variables here, and we are, that sounded kind of awkward, that's why I'm stumbling a bit. We're identifying variables here. Over here, we are using this method, and this is what it expects for the input. It expects what is going to be your features information, and then it expects the next one to be what is your target data. So our features are everything we want to pass in. Our target is going to be what we want the model to predict. This test size. So this is saying how much of this data do we want to be a test case. So this is going to be an 80-20. It's saying I want our test size to be 20% of this data. So that means 80% of it will be training for this model. And that's kind of a good ratio to have because you want enough information to train. You don't want to do it all testing. It won't make a very good model. You won't be able to learn much from the information. And then this random state 42. Let's see. So this is a seed for the random number generator. Let's see. Not entirely 100% certain about what this is doing, but it says by specifying a random state, you ensure the split is reproducible. You'll get the same split every time you run the code. I would have to look more into that to understand this random state a bit more. But the README also breaks down a little bit more about these scaled features and target. So scaled features is going to be a 2D array, which we can see we have, how many ever number columns across, and then a ton of data down. And then our target is going to be a 1D array or series. So our target is simply going to be 0 or 1. So it's just 1D. It doesn't come down and just do this whole column. Those are the two values in our target. Then again, it explains the test size that we're doing a 20% and our random state. So this is going to split our data into each of these variables. So we're going to have a training with the X. So the X is going to be our scaled features. So X train is going to be the 80% of this scaled features, and then X test is going to be the 20% of the scaled features. Y train is going to be 80% of the target, and Y test is going to be 20% of the target. And this is based on all these parameters here that we've defined. So X is going to be your first part, the features, Y is the target. Any questions about that? Okay. So I'm going to save it. I'm going to execute that so it's done. We can always look at your Jupyter variables to go ahead and see what has been put in each variable up to this point. So even though it's not outputting here, I can look down here and see that we have X test, whole bunch of numbers. And these are it's all the information from our data here. And same with the train, it's all the features. It's all the features data. And then our Y test and Y train is put there. value. I would have to do some more researching to figure out what this value means after the split there. So just to get a little tidbit though, you can go ahead and pull this up to look at what everything is in these variables up to the point you run. Okay. So next up, we have identified what's going to be our targeted features. We have split them. Now we need to convert them to tensors because our binary model cannot just accept these arrays. We're going to have to handle them in a way that our model can take. So we need to translate them into tensors using PyTorch. And we'll see if I just put this here, we can see it's missing the library import. So we're going to import Torch. Okay, so this should be kind of reminiscent of class on, I think it was Wednesday, maybe, the second day where you learned about tensors. So this is just assigning these variables to each tensor. So our training, our X-train tensor is going to be the X-training data. And it's going to be, we have to turn it into the float values. And then our X-test tensor is going to be X-test. Okay, easy enough. Now, when we get to the Y-train and Y-test, we can see we're doing something a little different here. We're doing this Y-train, grabbing the values, and then we're applying a view. Do you remember what the view was doing from class on Wednesday? Or has that already flown away? Anybody? You
It's gone. I don't remember.
said it's gone. Okay. So a view is a way to change the way this tensor is shaped. So our model expects all 2D tensors, correct? We cannot pass in a 1D, but this test, this Y train and Y test, when we split it, it's going to be 1D arrays. So we need to make it a two-dimensional in order to put it in this tensor and be able to use it in our model. So here we're taking the values and applying, we're changing it, making sure they're all afloat. And we're making it oh gosh, I looked into this. We're making it 2D this is the length of or I guess how can I explain this? We're using -1 to grab that last index in our array. So this way we can make sure we get all the values in our array, and then we're putting it on the 1 axis. So we're taking our 1D array and we say we want to change this view to go all the way down to the last value or last index and just put it on that 1 axis, which we saw was up and down. So let's go ahead and we're going to print. We'll see this. Let's print our Y test. Or, oops, I guess it doesn't matter because it's the same data, just 80/20. Let's run this one here. So we can see it has these zeros and ones here. I'm not sure how that's a 1D array, but okay. I think it's the way. I'm not sure what that. Let's see, potability, length, data. Okay. Let's see how it looks different when we put it in this Y-train tensor. Okay. Let's see how it looks if we don't. We're gonna take this view off. If we don't change it into this two-dimensional. the Y test tensor. Okay. So this is what it would look like if we didn't put it. It's going to be one long array, just continuously. But if we add that view on to make it this 2D. So instead of having just one big long array, it's now breaking them up into individual arrays all the way down to the last value here. So clear as mud. Just know that when we split our data in this specific case where we have just this one or the other output, a 0 or a 1, we need to go ahead and change it into a 2-dimensional array. So let's add this back in. Okay. We're going to rerun that. So now that we've handled everything. We've got our tensors, which are going to be the input for our model. And we went ahead, we did all our pre-processing here by replacing values that don't exist and identifying where our target and our features are, scaling it, standardizing it so we don't have any weird outliers, and then splitting it up into our tensors. So now we can take our model that we made the other day. Oh, well, you didn't make this specific one, but we're going to take our binary model. Okay, this class, this NN, that is from, is it Torch? Is it from Torch? I'd have to look back. Let's see. This was in yesterday.
Yeah, it is. It's in Torch.
Okay. Import Torch and N as, we just give it a alias. Okay. So we are going to have our class, our binary model that is going to take in these tensors, pass it through each of these. Oh my gosh, help me out here. The word's escaping me. Layers. Passing it through our layers. So we have our input. It's going to pass through these hidden layers, which are these linear ones here, and then this activation layer, which is our sigmoid, which is going to return just the output between 0 and 1. And that's what this sigmoid does. That's going to be the one or the other. So we create an instance of the model. And now, theoretically, if we did everything correctly, we can pass in our tensor and get a prediction. So right now, we're not going to learn about training or anything else like that. That's in future classes. We simply are learning pre-processing the data, being able to put it in the model and get something back. So I'm just going to, for example's sake, we're just going to pass in some of the testing or training. Let's see, we're going to pass in the training tensor. So let's print our model. We have to call our model because that is the object we instantiated here. And we are going to pass in the tensor. We're going to pass in xtrain tensor. Can't just pass in the train. And you can pass in the whole thing, but I'm going to just pass in the first row. So I'm going to pass in this at 0. I'm going to pass in pH, all these. And then I want to see if it can guess. So theoretically, this is not potable. So our model should tell us a value lower than 0.5. When we pass in, we're going to pass in this whole array of information here. So let's do that at this index. So we're going to pass in index 0. And we're going to also do one that is potable. So apparently our README has already done the work and found one that is. Again, we're going to pass in our xtrain tensor just because, and I guess index 406 apparently is a potable water. So we're going to see how this model performs. Okay, so let's go ahead. I am going to, this should be fine. I was going to maybe restart just to make sure everything is good, but I think we're fine. I'm just going to run it from here. All right, so this is what is output. The thing we're concerned about here are these numbers. These are between the 0 and 1. And what can we tell from these? Somebody tell me what this means.
Means no good,
No good. Why is it no good?
because we round down because it's not 0.5 and above.
Yep, so are both of these not good? So our model is doing what? It's determining, is this water potable based on all the rest of the stuff we pass in, right? So are they both not good, or is one not good?
Both are non-potable.
Okay, but this one, let's look at 0, index 0. That's actually an accurate guess. So the model guessed correctly for that one because it said that water is not potable. So that is correct. However, it's a little higher than I would like. I'd like it maybe to err more towards not potable, but it's fine. It worked correctly. However, this told us, since it's less than 0.5, that this water should not be potable. However, I put in a number that I knew was going to be a potable water. So this is inaccurate. What we can start thinking about maybe why this is inaccurate. What are some of the reasons? This is a little further than this lecture really goes, but why do we think maybe this is inaccurate? Our model. What could be some potential reasons that we could even address right now? Any ideas?
Is it something to do with the weight? I think that's what it's called, the weights of the tensors or something like that.
Yeah, so the model itself, this module that we have from PyTorch does a lot of it does that automatic weight and bias distribution through the layers itself. So we could mess with that, but if we think about it, I just passed in to this model just one row of data, and I'm expecting it to guess it correctly without any sort of learning or input. So this will kind of be leading on to next week's thing. In order to make this maybe more reliable, because obviously it doesn't perform very well right now, we could pass in more data and have our model kind of learn and adjust its weights and biases based on what's being passed in. And kind of that's where the learning part comes in. It's going to start taking in information and adjusting behind the scenes based on what we pass it. But for now, all we passed was one single row of data into our model. There's no learning, there's no nothing. It literally just went through these layers as best it could. Uh, so that is lecture today. We could also, I guess, this is part of your exercises. We'll stop recording before we discuss this, but there's some more things we can do to maybe help the model perform better based on what we do with our pre-processing our data. But any questions before I stop recording?
Yeah, for the binary model,
Mhm.
where I looked up really quick the linear just to remind myself the input and the output, right?
Mhm.
For the 9 and 7. I thought yesterday or last time we had class, yeah, Thursday, whatever, that it went from like 9 to 8, 8 to 7. Like why are we skipping here just to make it quicker, or is
So
there a
this
reason?
is, I mean, so this is the how much we're reducing the data each time, right?
Right.
So we're just dropping down faster. You
Because that
could,
that 9 is starts out as the amount of columns, correct?
it should,
Because I counted it. I think that's 9, not including potability because we
yes.
removed that earlier
Yep.
with the target.
Yep. So we're taking all of our data, yeah, and breaking it down each time into smaller subsets and passing through. Um,
Okay, so there's no like guidance that you may know about of like how to best break that down. If you just went 9 to 1, I guess I can experiment with that on my own and see what it looks like.
yeah, you can definitely throw in a few more layers in here. I'd imagine that the more layers, the better the network that it's building in the background. But that is definitely something you can play around with and see if
Right.
that does change. Maybe adding a few more layers, maybe it might make it more accurate. But yeah, I'll leave that to you to look into. This is just the way we decided to do this model. I don't know. We just have three layers in there, hidden layers. Any other questions? Okay. And again, all this pre-processing stuff, besides, the tensors, you can use for any data in any of your projects, not just in AI and LLMs. All right, well, I will stop recording. We'll go over our challenges for the day.